So, this whole generative AI revolution, it's happening, right? And man, is it hungry. It's just devouring computational power to learn, to create, to think. So the big question is, how do you even build an engine powerful enough for all that? Well, NVIDIA thinks they've cracked it. And it's not just a small step forward, it's a massive shift in how we even think about computing.
And there you have it, straight from NVIDIA's CEO, Jensen Huang. He's talking about the new Blackwell architecture, and he calls it a processor for the generative AI era. Notice he didn't just say a new chip. No, this thing was apparently built from the ground up for this moment. It's not just another upgrade, you know? It's a real statement of intent.
In this image, it just perfectly sets the stage, doesn't it? On one side, you've got Hopper, the reigning champ, the king of the hill. And on the other, there's Blackwell, the challenger, who is built for one very specific kind of fight. So yeah, this isn't just about a new product. It's a clash of titans. It's a story of the all-rounder versus the specialist.
All right, so let's get into it. And to really get what's happening now, we have to start with the reigning champion, Hopper. You've got to appreciate what a powerhouse this thing is. I mean, for the past few years, Hopper has been the gold standard. Period.
I like to think of Hopper as the decathlete of GPUs. It was built to be this balanced powerhouse, right? It could handle just about anything you threw at it. Complex scientific stuff like climate modeling? Yep. Training those early large language models? No problem. Its real strength was its versatility, its raw power in that traditional, super precise math.
Okay, so that's Hopper. Now let's bring in the specialist. And if Hopper's the decathlete, the all-around athlete, then Blackwell. Blackwell is the world record-holding power lifter. It's here for one thing and one thing only, and it's a total game changer. Blackwell's mission? It's crystal clear. To completely dominate generative AI. It's not even trying to be everything to everyone like Hopper was. Nope, this thing is engineered from the silicon up for one job, to handle these new, absolutely massive, trillion-parameter models. And it does it with an efficiency and at a scale that, honestly, we couldn't even really imagine before. So how do they actually stack up against each other? Let's do a tale of the tape. Let's look at the raw numbers, because this is where that whole story of specialization really starts to get interesting. Okay, take a look at these numbers. What's absolutely wild here is just the scale of the leap forward. Look at the performance for AI-focused tasks. For FP8, Blackwell is more than doubling Hopper's performance. And then you see the memory, the bandwidth, just massive jumps across the board. But the real kicker, the big headline, is that brand new line, FP4 performance. Hopper doesn't even support this. It's a whole new format, custom built just for running these massive AI models.
Yeah, 18 petaflops. Let that sink in for a second. That's 18,000 trillion calculations every single second. This is not just an improvement, this is a whole new weight class. It's Blackwell's knockout punch. And this power is specifically for AI inference, the part where the model actually gives you an answer. And what does that mean for us? It means faster, cheaper, and way more complex AI is coming for everyone.
So, you gotta be asking, how in the world does it pull off a leap like that? What's the secret sauce here? What is Blackwell's secret weapon? Well, it all boils down to this one thing, FP4 precision. See, it turns out that for generative AI, you don't always need to be perfectly, ridiculously accurate. Think about it like this. For a serious physics problem, you need a scientific calculator, right? But for a quick budget, you're fine just rounding to the nearest dollar. For a lot of what AI does, close enough is, well, it's good enough. And FP4 lets you get to close enough at an absolutely insane speed. And this chart really drives home the other half of the story, memory. I mean, just look at that jump. From Hopper's 80 gigs to Blackwell's 192, and the GB300 just takes it to another level. Why does this matter so much? Because when you can hold these gigantic models entirely inside this super-fast memory, you get rid of huge performance bottlenecks. It's simple. More memory on the chip means you can run bigger models with bigger context windows and get your answers way, way faster.
But here's the thing. This kind of specialization always comes with a trade-off. Blackwell doesn't win everywhere. And this is really important. For some super specific, high-precision science stuff, Hopper is still faster. This comparison shows it perfectly. Blackwell just crushes AI inference, no question, but Hopper can still hold its own and even win in the world of traditional high-performance computing. We're talking about things like complex climate simulations or drug discovery, stuff that needs absolute, perfect mathematical precision. The performance of one single chip is only half the battle. The real magic, the really mind-blowing stuff, happens when you link thousands of these things together. So let's talk about how they communicate. Hopper's NVLink, it was already really fast. Blackwell's, it's literally twice as fast. And this isn't just a nice-to-have speed bump. It's about scale. This new interconnect is the key that unlocks the ability to build a single, massive AI supercomputer from thousands of GPUs, a true AI factory. So what's the big takeaway from all this? When you add it all up, the laser-focused performance, the massive memory, that crazy fast interconnect, you realize we're at a really pivotal moment. The final verdict here isn't just which GPU is better. No, it's about a fundamental split happening in the entire world of high-performance computing.
What we're really seeing here is a huge strategic shift. The era of the all-powerful do-everything GPU, well, it might be ending. It's giving way to this new age of hyper-specialization. We're moving away from general-purpose tools and toward these purpose-built AI factories, designed for one single mission, to build the future of intelligence.
And this quote, it just nails it. This isn't just another generational leap forward. It's a fork in the road. Hopper was the peak of one way of thinking about computing. And Blackwell, it's the beginning of a totally new philosophy, a path that is dedicated 100% to the insane computational needs of massive large-scale AI.
And that leaves us with one last, pretty fascinating question to chew on. If you look at history, whenever we humans create these highly specialized tools, think about the telescope or the microscope, they end up opening up entire new universes that we didn't even know were there. So as our tools for computing become this specialized, this powerful, what new worlds are they going to let us build? What new frontiers of discovery, creativity, and intelligence are we about to unlock?